Key concept A, target A. The YouTube channel is at Math Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors. Mean, also known as the average. You're going to take the sum of all the numbers and then divide by the amount of numbers. Taking the sum means you're going to add them all up. So for example 1, find the mean of each of the following data sets, round to one decimal place if necessary. So starting with the example A, we're going to add them all up. So you're going to take 2 plus 5 plus 9 plus 3 plus 5 plus 4 plus 7, and we're going to divide that by how many numbers there are. So there are 7 numbers. When you add them all up, you're going to get a sum of 34. So the mean is going to be 35 divided by 7, which is going to give you a mean of 5. All right. For the next example, we're doing the same thing. We're going to add them all up, and then we're going to divide by how many. Okay. So when you add them all up, you're going to get a sum of 540 divided by the 6 numbers that there are. It's going to give you a final mean answer of 90. Okay. For neither one of these did we have to round because we got whole numbers as final answers. All right. The next thing we're going to be calculating is the median. It's the value in the middle when the data is ordered from least to greatest. If there are 2, we're going to have to take the average. All right. So starting with example A, we're going to order them from smallest to biggest. And as we write it down, we're going to cross them out from the list so that we don't accidentally duplicate one, or we don't accidentally write one too many times. So 2 is going to be the smallest value. Then comes 3. There's 1 4, 1 5. There's another 5, a 7, and then finally a 9. Okay. And all we're going to do here is we're going to take the same amount from each end until we end up with exactly 1 in the middle. So 1 from the left, 1 from the right, left, right, left, right. We're left with exactly 1 in the middle. So our median for this one is going to be 5. Looking at the one on the right, this one will be a little bit different because if you notice, there are 6 values, which is even. So you'll see that the answer is going to be a little bit different for this one. So again, ordering them from least to biggest, we have 2, 3, 4, 2 5s, and then finally a 9. And again, same process. You're going to eliminate the same amount from each end until we have 1 in the middle. So going from the left, 1 from the right, left, right. You'll notice we have 2 in the middle. So directions were, if there are 2, take the average, which means we're going to have to add them and divide by how many numbers there were. So the median, we're going to add them, 4 plus 5. And then because we added 2 numbers, in order to calculate the average, we're going to divide by those 2 numbers. So 4 plus 5 gives you 9. 9 divided by 2 is going to give you 4.5 as your final answer for the median. Now we're going to calculate the mode, the number that shows up the most often. It's possible to have no mode. It's also possible to have more than 1 mode. For this one, you don't necessarily need to put it in order. The reason I do is just because I think it's easier to spot when a number repeats when they're written in order from smallest to biggest. So that's what I'll do. Again, crossing them out as you go. 2, 3, 4, 5, another 5, a 7, and then a 9. Okay, so hopefully from here it's a little bit more obvious that each number only shows up once except for 5, which shows up twice. So in this data set, my mode is going to be 5. Okay, looking at the one on the right again, not that you need to, but I think it helps putting it in order from smallest to biggest. We have 2, another 2, 3, 4, a 7, and then 9, and another 9. Okay. Looking here, you'll notice that 2 shows up twice, and 9 shows up twice. So because they both show up the same amount of time, this one's actually going to have more than 1 mode. So the mode for this one is going to be 2 and 9. Okay. Keep in mind, if there had been another number, like let's say 4 was already in the set, right? If 4 has shown up 3 times, 4 would be my only mode because it showed up 3 times, whereas 2 and 9 only showed up twice. It's also possible, let's say each of these numbers only showed up once. So 1, 2, 1, 3, 1, 4, 1, 7, and 1, 9. That means each number only shows up once, so we would say that the set has no mode because there's no repetition. Range. Range is the difference between the greatest and the least values. The difference tells us we're going to subtract. So example 4 says find the range of each of the following data sets. We're going to take the smallest and the biggest, so starting with the greatest. For A, the greatest number there in the set is going to be 9. And we're going to take the difference, so we're going to subtract the smallest value, which is going to be 2 in this set. You subtract those two together, and you're going to get 7 as your final answer for range. One on the right, again, taking the biggest value. So in this case, the biggest value is going to be 78. And we're going to subtract the smallest value, which is 26. It's going to give you an answer of 52. All right, for 6A, we have an odd amount of values in the set. So in this case, we have 1, 2, 3, 4, 5, 6, 7 values. Directions for part A is to find the minimum, the first quartile, the median, the third quartile, and the maximum of the data set below. So we'll start with labeling it over here. Minimum, first quartile, also known as Q1. Median, also known as Q2. Third quartile, also known as Q3. And the maximum. Okay. Before we calculate any of these, we have to put our data set in order from smallest to biggest. And again, crossing them out as we go. We got 1, we have 3, 4, 8, 10, 12, and then finally 13. Okay. Now, I like to start with the min and the max because to me those are the easiest ones to identify right off the bat. So minimum is going to be the smallest value in the set, which should be the value all the way to the left, which is 1. Maximum is going to be the biggest value in the set, which should be all the way to the right. It's going to be 13. Now, Q2 is also known as the median of the entire data set. So that means we're going to have to cross one out from each side until we're left with just 1 in the middle. So cross out 1, cross out 13, cross out 3, cross out 12, cross out 4, cross out 10. And you're going to be left with 8 in the middle. So 8 is going to be our Q2. Now, our first quartile, Q1, is the median of the lower half. So ignoring 8, 10, 12, and 13, looking at only the numbers on the left, 1, 3, and 4, you cross out 1, you cross out 4. 3 is going to be in the middle. So 3 will be our first quartile, our median of the lower half. So we'll put that over here. Q3 is going to be the median of the upper half. So now we're ignoring 8, 4, 3, 1. And we're ignoring everything to the left. We're only looking at 10, 12, 13. Cross out 10, cross out 13. 12 is in the middle, so that's going to be our Q3. Okay. That's the final answer for part A. Part B says create a box and whisker plot with the values found in part A. So we need to draw a number line that goes from the minimum, which is 1, to the maximum, which is 12. So you can start with 1 if you want. So that'll be 1, 2, 3, 4, 5, 6, 7. Okay, going from the min to the max. Connect them like this, and we're going to draw the box and whisker plot above it. So we're going to put a tally mark over the min, which is 1, Q1, which was 3, Q2, which was 8, Q3, which was 12, and the max, which was 13. Okay, the box is formed by your Q values. So Q1, Q2, Q3, these three in the middle will form our box. And then your left whisker is going to be drawn from your minimum to Q1. Your right whisker will be drawn from your Q3 to your max. Okay, and there's your box and whisker plot for the values in part A. For 7A, we're looking at the same kind of example as 6A. The only difference here is that we, instead of having an odd amount of values, we have an even amount. So in this case, we have exactly 8 values, but we're still calculating the same type of information. So min, Q1, Q2, Q3, and max. So we're going to order the values from smallest to biggest, cross them out as you go. Again, the easiest one to calculate would be minimum, which is the one that is all the way to the left, the smallest. Your maximum is the biggest, the one all the way to the right, 17. Q2 is the median of the entire data set. Cross out 0, 17, cross out 2 and 11, cross out 5 and 9, and you have 7 and 8 in the middle. Since we have 2 in the middle, we're going to have to take the average. So we're going to do 7 plus 8, which is going to give us 15. And then we need to divide it by 2 because there was 2 numbers. 15 divided by 2 is going to give me 7.5. So 7.5 is going to be my Q2. Notice that 7.5 was not one of the original values in the data set. That's okay. It makes sense because there was 2 values in the middle when I try to calculate it. Now Q1 is the median of the lower half. So we're looking towards the left of 7.5. So 0, 2, 5, and 7. Again, we have 2 numbers in the middle, so we're going to have to add them and divide by 2. 2 plus 5 is going to give us 7. 7 divided by 2 is going to give us 3.5. So Q1 is going to be 3.5. Now we're looking for Q3, which is the median of the upper half, so we're looking towards the right of 7.5. So 8, 9, 11, and 17. Cross out 8, cross out 17. We have 9 and 11 stuck in the middle. Again, adding them together, 9 plus 11 gives you 20. 20 divided by 2 is going to give us 10. So Q3 is going to be 10. Now all that's left to do is to draw our box and whisker plot. Again, you want to go from min to max. This time around, I'm going to count by 2s. That's always an option you have. In this case, I'm counting by 2s just because counting by 1s from 0 to 17 will take a little bit of time. Way around that is going to be counting by 2s. Okay. Again, we're going to put tally marks over the minimum. Q1, which was 3.5, is going to be a little bit closer to 4 there. Q2, which was 7.5, again, going to be a little bit closer to 8. Q3 is 10. And max was 17, halfway between 16 and 18. Your box is made up of your Q values. Left whisker from minimum to Q1. Right whisker from Q3 to your maximum. Example 8A. So we're looking at 4 box and whisker plots. They're doing a comparison between class A, B, C, and D. They're looking at their arm span. Okay, so if you had your hands outstretched from middle finger to middle finger fingertip, that's what they're measuring here. A says which class has the least median arm span. Now, when we're talking about least median arm span, well, when we're talking about median, we're talking about Q2. So we're looking at these values that I just traced in yellow. Okay. If you look at your number line, it goes from 58 to 72. So the more to the left the number is, the smaller it is. The more to the right, the bigger it is. So they want the least one, so they're looking for the smallest one. So they're looking for the one that has it more to the left, which is going to be class C. B says which class has the greatest. Now we're looking for the one more to the right, which is going to be class D. Okay. The next question is which class has the largest interquartile range? Now keep in mind, range is when you take the biggest minus the smallest. But now we want to look at specifically the quartile. So Q1, Q2, Q3. I'm going to call this IQR for short. The IQR can be calculated. You're going to use the biggest one, which is Q3, minus the smallest quartile, which is going to be Q1. Okay. Keep in mind, Q3 is going to be the right side of the box, while Q1 is going to be the left side of the box. So we're going to calculate the IQR, the interquartile range for each of these classes. We're looking at Q3, which is right here. That looks like it might be 66.5, roughly. Minus Q1, which is right here. That looks like it's going to be 62.5. Subtracting these two together, you're going to get a final answer of just 4. Doing the IQR for Class B, Q3 looks like it might be exactly at 69, minus Q1, which looks like it might be at 63.5, okay, which is going to give us a final answer of 5.5. Looking at Class C, Q3 looks like it's right there at 65, minus Q1, which looks like it might be, it looks like it might be 62. Subtracting those is going to give us 3. And then the last one will be Class D. Q3 is right here. It looks like it might be 68. Minus Q1, which looks like it might be 67, roughly. Subtracting that gives you 1. So C says which one has the largest, the biggest value. So it looks like it's going to be Class B. And then which one has the smallest? That's going to be Class D. Hopefully by now you notice that there's a pattern here. The wider the box is, the bigger the interquartile range. The smaller the box, the smaller the interquartile range. And that's because when you're taking numbers that are far apart, their difference is going to be pretty big. But if you take the difference between numbers that are pretty close together, it makes sense that it's going to be a little bit smaller. All right, 9A. A basketball team had the final scores during the first 8 games of the regular season. 101, 99, 102, 101, 98, 146, 97, and 96. Calculate the mean and the median score. Describe which measure best describes the team's score. Okay, so let's start by putting them in order. We have 96, 97, 98, 99, 101, 101, 102, and 146. So we'll do median first, just because we already have them in order. So taking one from each side. You'll notice we have 2 in the middle, so we're going to have to add them and divide by 2. Okay, so we're going to end up with the median of 100. Now the mean says to add them all up. So basically, we're going to add them all up. Take your calculator, add them up. Your mean is going to be, once you add them all up, you're going to get 840. And you divide it by how many numbers there are. There is 8 numbers. So you're going to get a final answer of 105. Okay, so we calculated the mean, we calculated the median. Now we just need to describe which measure best describes the team's score. Okay. So if you look at the median is 100, the mean's 105. The first score was 101. That's only 1 point away from the median. The second score was 99, again, 1 point away. The third score was 102, which is 2 points away. The fourth score was 101, again, 1 point away. Fifth score was 98, 2 points away. 146 is 46 points away. 97 is 3 points away from the median. And then 96 is 4 points away. So notice most of those scores are pretty close to 100. They're only 1 or 2 numbers apart, with the exception of 146. If we look at the mean is 105. The first score was 101, that's 4 points away. The second score was 99, that's 6 points away. The third score was 3 points away. 101 is 4 points away. 98 is 7 points away from 105. 146 is 41 points away. 97 is 8 points away, and 96 is 9 points away. Notice that the mean is further away from the actual scores that we got. So If you had to describe which one of these better represents a team score, it would be the median, because the difference between the actual score and 100 is much less. Okay, this team is more likely to score 100 points on any given night than they are 105. That's not to say that they won't ever score 105. They're just more likely to score 100 points. Okay. Obviously, what's throwing off the data here is the fact that there was one game where they completely dominated and they got 146 points, which is not usual for them, anyways. Okay, so putting that in a sentence, the median of 100 best describes the team score because it is closer to what they normally score. Number 10A. The plots below show the distribution of scores on a math homework checkpoint for 2 classes of 18 students. Based on the mean, median, determine which class performed better on the homework checkpoint and explain. Okay, so the 3 x's above the 0.0 means that 3 students got a 0.0. The 3 x's above the 1.0 means that 3 kids scored a 1.0 on the homework checkpoint score. All right, so we're sort of comparing periods 5 and period 7. So let's start with period 5. We're going to go ahead and calculate the mean. So you're going to do 0.0 plus 0.0 plus 0.0 plus 1.0 plus 1.0 plus 1.0 all the way till you get to 5.0. Okay. A faster way might be doing 0.0 times 3, since it showed up 3 times, plus 1.0 times 3 because it showed up 3 times, and so on until you get to 5.0. Okay. You add them all up, you're going to get a total of 45 divided by the number of students, 18, the number of x's, 18, and that's going to give you a mean of 2.5. Okay. Now, for the median is a number in the middle. Okay. You could list them all out, 0.0, comma, 0.0, comma, 0.0, comma, 1.0, all the way to get to 5.0, and then take one away from each side at the same time. Or we're going to just do it like this. We're going to start at 0.0. We're going to curve this way, and that way, all the way till we end up with 5.0. Okay. And then we're just going to take away from the same side, from each side, the same amount. 1. Okay. Notice we're traveling in opposite directions until we get to the middle. You'll notice that there's 2 in the middle here, a 2.0 and a 3.0. So we're going to have to add them and then divide by 2. So 2 plus 3 is going to give us 5. 5 divided by 2 is going to give us a median of 2.5. Okay. Now we need to do the same exact thing for period 7. Okay, so let's start with the mean. We're going to add them all up, and we should get a total of 62 divided by the number of students or test scores or checkpoint scores, 18, and that's going to give us 3.4 repeating. So 3.4, and this little symbol above the 4 lets me know that it repeats. Now we need to calculate the median for this one. Okay, so again, starting with 0 and ending with 5.0, we're going to take the same amount from each side. You'll notice again there's 2 in the middle. This time they're both 4.0s. So 4 plus 4. 4 is the same thing as 4.0 divided by the 2 numbers that we just added. So 4 plus 4 will give us 8. 8 divided by 2 is going to give us a 4. All right. Now, we calculated the mean and the median. Now we need to determine which class performed better on the homework checkpoint. You notice that period 7 has the higher mean, and it also has the higher median. So it's pretty obvious here that period 7 did better than period 5. Right? So in a sentence, period 7 performed better because they have a higher mean and median. During the 7 tests that Marissa took in semester 1, she averaged a 4.0 with a standard deviation of 0.2 per test with normal distribution. During the 5 tests, Jackie averaged a 3.5 with a standard deviation of 0.5 per test with a normal distribution. Use the normal curve diagram to complete the following question. Okay, so starting with Marissa, this is all the information about Marissa. The value in the middle should be our average, or Marissa's average, which is 4.0. And her standard deviation tells us what to go up by. So her standard deviation was 0.2. So going to the right, we're going to add it by 0.2. So this would be 4.2, 4.4, 4.6. Going in the opposite direction, we're going to subtract. So that makes this 3.8, 3.6, and 3.4. Okay. Now, we want to know what the percentage would they expect to 4.0 or higher. So you'll notice that here's a 4.0, and then to the right is higher. Okay, so we're going to add up all those percentages. So this should be 34 according to this picture right here. This should be 13.5. This should be 2 and 0.5. You add those all up and you're going to get 50%. So Marisol is going to score a 4.0 or higher 50% of the time. Okay. Now we need to do the same thing with Jackie. Now we're told that Jackie averages a 3.5, so down the middle we can put 3.5, and her standard deviation is 0.5. So going to the right, we're going to add by 0.5, which is going to give us 4, 4.5, 5.0. Going in the opposite direction, we're going to subtract, so this is going to be 3.0. 2.5, 2.0, and again we want to know what the percentage is. She's going to score a 4.0 or higher. Here's the 4.0, and higher would be to the right. So again, looking at this diagram right here, this one right here should be 13.5, 2, and 0.5. Adding those all up, you're going to get 16%. Okay. Question B says, by these statistical measures, who would you consider the better student? Okay, well, Marisol is going to score a 4.0 or higher 50% of the time, whereas Jackie's only going to score a 4.0 or higher 16% of the time. So Marisol has a higher percentage, therefore she would be considered the better student. Okay, so we'll put that in a sentence. Marisol would be considered the better student. Because she has a higher percentage of scoring a 4.0 or higher. Because her percentage of scoring a 4.0 or higher is greater.